The next topic is solubility of liquid in liquid, liquid in gas, that one. What is the last topic there? Distribution law. So these two laws, diffusion law and distribution law, are separate. So we'll study this in a short, and then we'll move on to the next topic. Next topic is distribution law. The next topic is distribution law. Today you are going to do that experiment. That's why. Who is going to do that experiment? Which batch? Second batch. Okay. So you are going to do this experiment. I will now listen. I will explain the process. I will explain the process. I will explain the concept. Now you create the definition. You create the equation. Okay. You have to create. Now the name is saying distribution. What do you mean by distribution? Something is separating from here to there. Something is separating from here to there, hence the name is distribution. Why I am pointing out on this? Because to create equation, this distribution, this concept is very, very important. You are going to create that equation for this. So what they found is, scientists, they took oil. I am writing oil upside. Why? Because generally oils have less density. So I am writing oil here. This is water. They took oil and water and they added a solute here. They took oil and water and they added solute. Now this solute which is added, they never took that concentration to saturation. The concentration is below saturation. This law is applicable only the concentration is below saturation. Whatever the scientist added the solute to oil and water, they are miscible, they are not immiscible. So for time being we call that system as immiscible system. They added a solute to immiscible system in which concentration? Below the saturation. Below the saturation they added the solute. They left it. Okay, and they shake, they left like that. Now first solute will come to this one and slowly it will go to oil also, water also. Solute will transfer from oil to water. Okay, there are many questions coming to you. When it is oil soluble, why it is going to water? Yes, it will go. I will tell you why. Okay, so solute is going to water. Then it won't stay there. Depending on its hydrophobic and hydrophilic groups, if hydrophilic groups are more, all solute will accumulate here. If hydrophobic groups are more, solute will try to stay in oil phase more. Listen once again. When your solutes hydrophobic groups are more, it will try to stay in oil phase more. It will go to water, but suddenly it will come back to oil. If the solute hydrophilic groups are more, then it will stay in water for much time compared to oil. Compared to oil, it will try to stay in water for much time because it has more water loving groups. In either the case, the solute is transporting from here to here, here to here. This is called distribution. The solute is distributing from one phase to other phase. So continuously it will traveling. Remember, solute will be continuously traveling. The traveling speed will decrease in particular phase depending on which type of group it has. Okay, what I am trying to say is, come here. Come. You also. Come. 3. Go there. Assume this is oil. Come. While walking, don't. Okay, go that side. This is oil. Assume me has a interface. This is water. Who is there? Outside or inside? Okay. Assume this is oil phase, this is water phase. We just added solute to oil. Now these solutes have more water loving group. Assume. Okay. Now what they will do? They will run fast. From oil to water you have to run fast. From there you need to come slowly, step by step. See? Slow. Why they are moving slowly? Because they have water loving more. Hence they are staying in water more. Okay. But once they come to oil, again they will towards. Okay, they will be moving. Remember, here the point is, you get, if you measure the concentration in oil and water, please sit down, thank you. Okay, if you measure the concentration in oil and water, if you measure the concentration, if that group is having more hydrophilic groups, the concentration will be more in water. If that solute is having more hydrophobic groups, the concentration will be more in oil. Okay, concentration more in oil. Now what they observed is, they took 1 gram of solute, they did this experiment. They took 2 grams of solute, they did this experiment. They took 3 grams of solute, they did the experiment. Today you are going to do experiment for 0.5 gram, 1 gram and 1.5 grams. Just for time being, assume I have taken 1, 2, 3. Okay. They conducted the experiment. They measure what is the concentration in oil phase. They measure what is the concentration in water phase. Okay. Now how to, after measuring the concentration in oil phase and water phase, because here it is up, so they written concentration oil. Here it is down, so they written concentration water. So they ratioed it. They ratioed the concentration. What they observed is, this ratio, for 1 gram the ratio is, let's say 0.4. Assume the ratio is 0.4. What they observe is, for 2 grams also 0.4, for 3 grams also 0.4. Means what is happening? The ratio is remaining constant. So they kept it as constant. I explain once again. When scientists, what they did, they took oil phase and water phase, they added solute to this. Listen to me carefully. We created, already equation is created there. Okay, you need to create definition. That is very, very important. When scientists added solute to two immiscible solvent, that is oil and water, what they found is, this solute will distribute. Okay, once they attain equilibrium, you should measure the concentration only when, see, if I added now and now only I am measuring, obviously the concentration will be more in oil, because I added in oil phase. You need to wait. After adding, wait, keep constant temperature. Temperature should be constant, remember. Okay, temperature should be constant. Keep constant temperature, you add the solute. Wait until it attains equilibrium. What do you mean by equilibrium? Means number of molecules going from oil to water and water to oil should be same. Equilibrium means we added 100 molecules, they have more oil water loving group. Assume 100 molecules have more water loving group. 60 molecules will stay here, 20 molecules will stay there. What is the equilibrium movement here? What is remaining? 20. So 20 will go here, 20 will come here, or 10 will go here, 10 will come here. They will be keep on moving. This is called equilibrium. So scientists added the solute in two immiscible solvent and they wait until it attains equilibrium. They kept the concentration temperature constant. Okay. They gradually increase the amount of solute they are adding. They did 3 experiments. They gradually increase the amount of solute they are adding. Now what they did is, after attaining equilibrium, they measured their individual concentration. Concentration in oil, concentration in water, and they divided the concentration. After dividing, what they found is, for 1 gram solute also the ratio is constant, 2 grams also ratio is constant, 3 grams also ratio is constant. Because ratio is constant, they kept the name as constant and they kept as D because it is distribution constant. Now again, we are not naming as a distribution constant because it will change if we change concentration, it will change if we change temperature. So we call it as distribution coefficient. This is the equation for distribution law. Now define the law. Whatever I just said the story, I just said you one story. Scientists have done this. Collaborate that story, you will get the definition. It is defined that at equilibrium, No, come to first. Before equilibrium, what we are doing? We are adding. It is defined as when you when solute to immiscible solvent at equilibrium. Very good. The ratio concentration of solute is constant. What is textbook is saying? See what you created, I will tell you. They said that it is defined as when solute is added to two immiscible solvent at equilibrium and constant temperature, the ratio of concentration is constant. Read it. First only it is given, see.
Distribution law states that when a solute distributes between two immiscible liquids at equilibrium and at constant temperature, the distribution ratio of a solute is constant.
See?
Which is a dimension.
You created the definition. You should know it. But he has written in some formal way. We created in a raw way. If I am writing the textbook, this will be my definition. That is the Subramaniam's definition. But my definition is this one. You just created the definition. Yeah, name it as my definition. Okay, this what is distribution law. Now, why I am telling this? Today you are going to do batch 2. You are going to do this experiment. What we are going to do is, you are going to distribute benzoic acid. Benzoic acid you are going to distribute in benzene and water. You will be given with benzene and water, and your sir will ask you, he will create the groups. Individual group, he will give you individual values. So one person will be adding 0.5 grams of benzoic acid, second person will be adding 1 gram, third group will be adding 0.5 grams. But remember, to start this distribution experiment, you need to add the solute not after mixing two immiscible solvents. Yeah, you need to take water here, take benzene here. See that where solute is more soluble. So benzoic acid is more soluble in benzene. It is weak acid, hence it is more soluble in benzene. So you need to add your 0.5 grams of benzoic acid in given amount of benzene. Okay, given amount of benzene. Here I will tell you, in this experiment you have so many doubts. You will be adding 0.5 grams in benzene, then this benzene is transferred to water, and you have to shake it. To attain equilibrium, you need to shake it, because if you keep like this, it will take 2 days to attain equilibrium. It will take time. When you shake it, this oil will convert it into droplet and it mix with the water. Temporarily you are going to create emulsion, but that emulsion will break because there is no emulsifying agent. Benzene along with benzoic acid will enter into the water in the form of drops when you shake. Because there are drops, surface area is increased, so there will be more distribution and more readily you can attain equilibrium. So you should shake for 5 to 10 minutes. While doing the experiment, keep a note that after shaking, if you feel tired, you should not keep on your hand because temperature will change. If you are keeping hand, you can keep, but all 3 groups should keep their hand, and all 3 group persons should have same temperature. Otherwise you will get different values. If you do this experiment correctly, all the groups will get same value. That is the experiment. If you do this experiment correctly, all the groups will get same value. Another catch here is, we are taking only 30 ml of benzene and we are taking 100 ml of water. Can you tell me the reason why we are differentiating here? As per law, we never mentioned that you need to take this much only. You could have taken 100 by 100. Here we are taking 30 by 100. There is a reason. Lies in the property of benzoic acid. Huh? Very strong base here. Listen to me, be with me, you learn the concept, you won't forget. If you listen to me, you never forget. No need of to study for exam also. You can create it. 30 ml, 100 ml. One property of benzoic acid. I said this is a weak acid. So it is having less solubility in water, it is having more solubility in benzene. When solubility is more in benzene, to compensate this solubility, to adjust the solubility, we will take more water. We will take more water to compensate the solubility problem, because your benzoic acid is more soluble in benzene. Because if you take 30 ml water, it will try to stay in benzene only. To avoid that, we will take 100 ml of water. We compensate the solubility property with volume of water. What I said, what do you mean by solubility? How much parts of water is required to solubilize. If I increase the part of water, obviously solubility will increase. So to match the solubility, thrice this I will take. Thrice that I will take. Then the solubility will be matched. And then benzene will start going, benzoic acid will be start distributing from here to there. Okay. But there are some limitations to this law. Okay. There are some limitations. We try to see this in next class. Okay, listen. There is a problem that solute has to behave as solute in both the solvents. It should not dissociate, it should not associate. If solute dissociates, let's say solute is dissociating in water, in that case the law will change like this. We'll write square here. If solute is associating, some solutes are there, they are forming dimer, trimer, we don't know. Dimer means two solutes together, dimer. Trimer, three solutes. In this case, if it is forming dimer, because generally they form dimer in oil, hence I am writing like this. If they form trimer, cube root. This, where is this equation is not applicable when solute dissociates or associates. This equation is only applicable when the solute is behaving as naturally. When it is behaving naturally, then only this equation is applicable. That's what it is. Okay, see, we'll see these limitations in tomorrow class. Very important 5 marks question. Define distribution law, write its limitations. Very, very important. Okay.